today's lesson is called Logarithmic Differentiation. So previously we talked about how to take the derivative of a certain function. This time we're going to use logarithmic to help us to take complicated derivative. So let's look at example 1. Find the derivative of y equal to x minus 2 squared all over square root of x squared plus 1. Now, if you were to take the derivative without using logarithmic differentiation, we will have to use a quotient rule along with two chain rules. Now, using the logarithmic differentiation, we could avoid using those complicated and multiple rules. It's called logarithmic differentiation, so therefore we'll need a log. Specifically, we're going to use ln, natural log. So we're going to take natural log to both sides of the equation. So it will look something like this. So on the left side, we'll have natural log of y. On the right side, we'll have natural log of x minus 2 squared all over square root of x squared plus 1. Now, using the properties of logarithmic, we're going to actually expand this, the right side of the equation. So we will still have natural log of y, and this will become 2 times ln of x minus 2 minus 1 half ln of x squared plus 1. Now we're going to take the derivative of this equation implicitly. So ln of y becomes 1 over y times y prime. 2 times ln of x minus 2 becomes 2 over x minus 2. 1 half times ln of x squared plus 1 becomes 1 half times 1 over x squared plus 1 times 2x. Again, let's simplify that. So it becomes 1 over y times y prime, 2 over x minus 2 minus x over x squared plus 1. Now our goal is to solve for y prime, so we're going to multiply y to the other side. So we could say y prime is equal to 2 over x minus 2 minus x over x squared plus 1. This whole thing will get multiplied by y. Now if you look carefully, this y needs to get replaced, and this y is equal to our original equation, which is x minus 2 squared over square root of x squared plus 1. So if you substitute, your y prime will equal to 2 over x minus 2 minus x over x squared plus 1, and this whole thing will get multiplied by x minus 2 squared over square root of x squared plus 1. Now we just have to distribute this in, and you will have your answer. So y prime will equal to 2 times x minus 2 over radical x squared plus 1 minus x times x minus 2 squared over x squared plus 1 to 3 over 2 power. And here is your derivative. Now let's look at a second example. Second example states find the derivative, and now your equation is 3x minus 2 to the 4th power over x squared times square root of x plus 1. So once again, we're going to try to take the derivative using logarithmic differentiation method. So we're going to try to take natural log to both sides. So it'll become natural log of y equal to 4 times ln of x minus 2 minus 2 ln of x minus 1 half of ln of x plus 1. Again, notice that I expanded all together as the first step. Now we're going to take the derivative using implicit. So 1 over y times y prime. This will become 4 over 3x minus 2 times 3 over 1. This 2 times ln of x, derivative will be 2 over x, minus derivative of 1 half ln of x plus 1 is 1 over 2 times 1 over x plus 1. If you simplify this equation, you get 1 over y times y prime, 12 over 3x minus 2 minus 2 over x minus 1 over 2 times x plus 1. Again, a lot of students tend to distribute this in. My suggestion is do not distribute your original equation of ln, such as x plus 1, x, and 3x minus 2, because you will simplify by dividing or multiplying in the next step. We're going to try to multiply y to the other side. Y prime is equal to 12 over 3x minus 2, 2 over x minus 1 over 2 times x plus 1. Okay, this whole thing will get multiplied by your y, which happened to be 3x minus 2 to the 4th x squared times square root of x squared plus 1. The final step will be just distributing that in. So y prime will equal to 12 times 3x minus 2 to the 3rd over x squared times square root of x squared plus 1. The second term will be 2 times 3x minus 2 to the 4th power over x to the 3rd times square root of x squared plus 1, and your final term will be 3x minus 2 to the 4th 2x squared times x plus 1 to 3 over 2 power, and here's your derivative of 3x minus 2 to the 4th over x squared times square root of x plus 1. Last example, example 3. Find the derivative of y equal to sine of x to the x power. So another purpose of using a logarithmic differentiation is to help us to take the derivative of a function to another function, like in this case. Notice that we have sine of x, which is a function, and if you look at the exponent, we have a function called x. So logarithmic differentiation could also be used when you have a function to another function. So we will start by taking the natural log to both sides of the equation. So we will have ln of y equal to ln of sine of x to the x power. Again, by the property of the log, we could bring out the exponent to the coefficient, so it becomes x times ln of sine of x. Now we will take the derivative implicitly, so this will be 1 over y times y prime. Now this requires product rule, ln of sine of x plus x times cosine over sine. Now we're going to move the y to the other side by multiplying. So y prime is equal to ln of sine of x plus x times cotangent of x, and this everything going to get multiplied to y. Now let's substitute y back in. So we'll have ln of sine of x plus x times cotangent of x, and your y in this case was sine of x to the x, and we will distribute and we'll have our answer. So our answer will be y prime is equal to sine of x to the x power times ln of sine of x plus x times cotangent of x times sine of x to the x power. And here is our answer. Now to summarize a logarithmic differentiation method, your first step will be taking the natural log to both sides of the equation, and then expanding the logarithmic equation if necessary. After that, you will take the derivative implicitly, then multiply your y to the other side of the equation. So you could have it as y prime equal to an equation. Substitute your y with the original equation that you started with. And the last step will be simplified by distributing your y. And that's how you take the derivative using logarithmic differentiation.